Get set up here. I gotta get Windows rearranged. Okay, so this is going to talk specifically about OpenACC. So there's two Pragma-based languages, OpenMP and OpenACC. So AMD primarily supports OpenMP, but you can compile code that uses OpenACC for the AMD GPUs. So these are mostly compilers set up on that are based on GCC, and you can actually, if you install on your system the offload package for your for the GCC compiler, it will generate code for up through the MI100 series of the AMD GPUs. Siemens Sorcery compiler is developing more support for OpenMP, OpenACC with the Fortran compiler. So there should be better support within the GCC branch once that gets merged in. That is available to be tested for feature completeness at this point in time. It's nearing completion to be merged into the GCC 13 branch. You also have the option of the Cray Fortran compilers. Now, the Cray C and C++ compilers no longer support OpenACC, but the Fortran compiler still does. LLVM has stated that they will focus on OpenMP, but they said they would support an OpenACC to OpenMP translation. I'm not sure what the status of that is right now, but there are some future support in that area with the LLVM series as well. So what is the difference from the OpenMP version? Well, the pragmas are slightly different syntax. So you replace one line in the OpenMP version with this line in the OpenACC, and you have a code which will work with OpenACC-based compilers. So here's an example of the Fortran vector add with OpenACC. We're not going to do this exercise because we don't have Sorcery compiler on the Lumi system. Why am I going over this? Well, you may want to do this locally on one of your local workstations or local HPC systems to be able to develop code, and then you can go to the Cray system and use the Cray compiler for running on Lumi. So this makefile, you can set different, you can set the FC environment variable so that you can try different compilers. And basically what you're doing is setting the path and location for the libraries and the include file. With the Siemens Sorcery compiler, their executable name for the G-Fortran compiler is fairly long. So on our local system, we soft link it to a simpler name. I would suggest that you do the same on your system so that you're not using that long name. and then but it should be something specific so you know you're not getting the system G Fortran. You can get more verbose output during the run with these flags at the bottom of the slide. And the this is for the GCC version of the compiler. It will give you some output telling you whether it ran on the GPU or not. That's one of the problems. Sometimes you compile the code and don't realize you're still running on the CPU. So it's always good to confirm that you're running on the GPU and not getting misled that you've got the code working on the GPU. So the make file is fairly simple, and you can set the GPU target, the ROCm GPU variable if you want to override the auto detection in the make file. So in testing this this example, the Siemens GCC compiler will compile that and run it on the MI200 series. The Cray HPE compiler will also compile it. If you're running on an MI100, the GCC 11 and 12 will also generate code, the default system, but you do have to load an offload package for the GCC compiler to make that work. And you can, on the Cray system, you can use this Cray ACC debug to tell to give more information about what's happening. You can also see there's during the compile, you can use the -H list, and there's an AIMD. Each one of those letters specifies different output during the compile. Also, -H messages can give you more information. So you can try this on your local system or try it with the Cray OpenACC compiler. And we are actively trying to get reports with applications for issues of things that are not properly supported. So we're focusing on feature completeness with the OpenACC compilers right now with the GCC Siemens compiler, and we're also the Cray compiler is trying to fill in some of the missing items that they do not have complete within their compiler. So if you have issues, please report them. So there are conversion utilities. Some teams are converting to OpenMP instead of OpenACC. So the CLAC tool will do a conversion, and Intel also has a conversion utility that they have just released recently, and that's supposed to be fairly good too. I don't think either of these are perfect, so you may have to do some work to complete the port. And so, in summary, we have many features still being added to these compilers and support for OpenACC. That's also true with OpenMP, that there's some features that are not complete. And we're also asking for feedback for those compilers as well. If the HPE Cray compilers are more mature, they've been out for quite a few years right now. They are fairly complete with older versions of the standard, and they're trying to catch up with the latest standard releases of OpenACC and with OpenMP. OpenMP is getting stronger development support in general, and we keep looking for OpenMP to take over from OpenACC, but it seems to be a long transition. You may get different types of error reports, so these aren't always obvious what they're complaining about. So if you get a memory fault, it may be because data is not present on the GPU, and if you get this overlap, host region overlap message, I found that may occur because you may have mapped it to the device, but not deleted or released it, and so it complains about that data as well. And that's it for OpenACC. We do have mention of OpenACC in some of the other presentations. So this is just to mention the specific situation for OpenACC and in particular with Fortran.